In the previous video, we discussed the as a theory part of the hydrostatics part 2. Now we are going to discuss the problem based on that. Now please go to the first question. What is there? So a body floats in liquid contained in the beaker. The system is falls freely. We discussed a theory part that whenever the given system is in accelerated frame, with the buoyancy force can be written as F buoyancy. So F buoyancy is equal to V solid into rho liquid into here. Since it is accelerated from, instead of G I can write this has to be G effective by using the concept of as a pseudo force. Therefore, I can write that this pseudo force in the case of lift is accelerates down. For this case, downward case, the G effective is nothing but G minus A. For free fall, we know that for free fall, since A is equal to G, therefore G effective is 0. So therefore F buoyancy is 0. So that is the answer for that question. Now we go for the second one. Now you please go for the second question. That is the second one. A wooden block of so volume of the solid is given as to be 1000 centimeter cube, and its weight in air is 12 Newton, and they are suspended. Half of the block is in water. So what will be the spring balance reading? Note that always spring balance measures the apparent weight, and just see that FB formula we know that, and moreover that apparent formula. So the weight of the object, apparent weight of the object, that is given by W minus F buoyancy, that is the apparent weight. So that spring balance will measure this apparent weight only. So for this question, now you see that W apparent that is equal to W weight in air. This is called actual weight, that is 12 minus. So 12 minus, now you see that this is minus F buoyancy is nothing but volume of the solid. Half of the volume is there. Solid volume is inside this liquid, so therefore V by 2 is a rho liquid. So rho liquid is there. So since what is there, so rho liquid V in, instead of V in, V by 2 is there, into G. So now you see that 12 minus volume is 5000 and half of that volume is 500. So 500 into 10 to the power of minus 6 centimeter cube is converted into meter cube into the density of the water. Here liquid is water, 10 to the power of 3, and this has to be G 10 to the power of 1. Therefore 3 1 4, and here 2 is there 6. So therefore I can get 12 minus 5. So W apparent. So this W apparent is the reading of the spring balance. So therefore I can say that the reading of the spring balance is W apparent, that is equal to 7 Newton. Now the next question, say this is question number 3. So iceberg floats in sea water. The density of the ice is given 0.92 and sea water density is 1.03. What percentage of the iceberg will below the surface of the water? When you study the applications of flotation, there we wrote that fractional volume in, that is nothing but rho solid divided by rho liquid. Okay, so that is given. In terms of percentage, if you want to means, you just multiply by 100 over there. So I can write that F in. So F in percentage, that is given by solid density, that is 0.92 into 100, here is there, divided by density of the water is 1.03. So just to solve this, you can get that is approximately 89%. Now we go for the another question. So question number next question. So now you see that a solid floats in water with 3/4 of its volume. That take care of the question number. So a solid floats in water 3/4 of its volume below the surface of the water. Calculate the density of the solid. So since it is floating, therefore I can write that W equal to FB. Therefore I can say that W, take care of the question number here, take care of the question number. Therefore W is equal to FB, and this W is nothing but M into G, or M can be written as V into rho. So therefore V into rho G, that is equal to, this is V, but they said 3/4 of the volume is inside, 3/4 of the volume of the solid is inside, into density of the liquid. So rho liquid into G. So therefore this is the solid. Now you see that Vg gets cancelled out, therefore rho solid that is equal to 3 by 4th of density of the water. Density of the water is here, liquid is water, therefore 1000. Therefore, I can write that 3/4 of this value into 1000, that is 750 kg per meter cube. That is the answer for that question. And the same thing, the another one is there. So please take it up the question number. I can write here. So the another question. The weight of the solid in air is given. So W air is given as that has to be, yes, take it up the question number, yes, for your reference. So yes, W air is given as to be 10 Newton, and it is weight is decreased in water has to be. So therefore, weight of the solid in is water, that is weight loss of the solid, that is given as to be Wn. This weight loss is nothing but generally W air minus W water. Yes, that is the thing is given. They are asking what is the density of the solid. So we know that relative density of the solid is nothing but rho solid divided by rho liquid. Here liquid is water, so that is equal to, yes, W air divided by, yes, W air minus W water. This value is given as to be 2 here, so therefore W air minus W water. Yes, so substitute that value, that is 10 by 2. Therefore, rho solid, that is equal to 10, 5, this is 5000. So 5000, because density of the water is 1000, you just cross multiply that, we can get 5000 kg per meter cube. So go for the another question. Yes, so kindly take care of this question number. So there is a slight correction, please take care, don't confuse with that. Now question number 5 is there as per the slide. So the wood is at an 0 degree centigrade, the corresponding volume is V. When temperature increases from 0 to 20, what will be the change in V by rise in temperature? Since it is floating, we can write that W is equal to F buoyancy. That F buoyancy is nothing but volume of the solid inside the liquid. So remember this formula, volume of the solid inside the liquid. So since here instead that volume of the solid is nothing but that V is the volume at 0 degree, and say for example V dash. So V dash is the volume at 20 degrees. So V dash minus V, that is change in volume of the solid by the temperature change. Into, since rho is change with respect to temperature, therefore rho temperature for this liquid. So into G is there. So from this I can write that yes, V dash minus V, that is equal to W divided by rho T into G. So therefore from this I can write that V is equal to V dash minus W by rho T. In the previous video we saw that the temperature dependence of is density, that is rho naught 1 minus gamma delta theta, change in temperature into G. So some term is subtracted from the final volume, therefore I can say that V is less than V dash. So volume of the initial volume is less than the final volume in this case. Now you see the another question here. So that is question number 6. Yes, as per that. So question number 6. A barometer kept in elevator. So since the same question as we discussed earlier, now the initial pressure, the atmospheric pressure, we can write that H rho G. H and G are constant, therefore I can write that P is directly proportional to G. This is the normal condition. When the lift is accelerated upward, the pseudo acceleration is downward, therefore G effective is G plus A in downward direction. Therefore P dash is proportional to G plus A. So therefore P dash is greater than P. Since just compare this, obviously P dash is greater than P. So when lift is accelerates, then the barometer shows the high pressure more than that 76 centimeter of mercury. Go to the next question. Yes, the next question, say for example question number 7. A solid of density sigma floats in the liquid. So floats means we can again say that W is equal to F buoyancy. This is nothing but mg, that is equal to, this is F buoyancy. F buoyancy is nothing but volume of the solid. Say that is the initial volume has to be say for example V naught, volume of the solid inside the fluid into density of the fluid. So density of the fluid is given, that has to be rho here. into G. So G gets cancelled out, therefore I can say that V naught is equal to m by rho. Take care of the symbol, rho is density of the liquid. Yes. Now when the solid melts, the molten solid can occupy some volume. So therefore volume of the molten solid. So molten solid is say for example V, that is equal to m by the density of the solid is given as to be sigma. So these are the two results what we get. By comparing these values we can get the following results. So that is now you see that suppose V is greater than V naught, that means m by sigma, this is for a solid and that will be for the initial case. This is a final case and initial case is greater than the m by rho. Yes. So when the final volume is that this V is greater than V naught, we can say that there is a rise of liquid level will be increases. And suppose they are V is less than V naught, by writing the same condition m by sigma V less than m by rho, therefore we can say that there is a fall of liquid. Suppose they are equal, the densities or the volumes are equal, then there is no change in the fluid levels when E is equal to V naught. So that is the inference what we get. And go for the another question. So go for the another question. Now you see that in this question, for our reference we can say that is question number 8 and solid. So again this is the problems related to non-inertial frame. So now you see that I am converting non-inertial frame into inertial frame by considering the pseudo acceleration or finding the G effective. So this is the free body diagram. So the upward force is F buoyancy, and this is the thread attached with the bottom of the container. So tension T and the weight of the solid is W is acting there, and I am taking this has to be sigma, this has to be rho. Now please come to the discussion. The case 1 is what is the tension in the thread connected in that. Since by using G effective concept, actually the system is accelerated upward, but G effective, that is nothing but G plus A. In the case of the system is accelerated upward, G effective is G plus A. Therefore I can say that G effective in this case 12 meter per second square, 10 plus 2, 12 meter per second square. Okay. Now please come to the discussion. Whenever the system is converted from non-inertial to inertial frame, then we can say that net upward force equal to net downward force. Therefore T plus W, that is equal to FB. Yes. So from this I can write that T is equal to FB minus W. FB minus W. Therefore F buoyancy is nothing but volume of the solid into density of the liquid, liquid. So rho liquid into G minus W. Yes. So that is W is nothing but mg divided by. So now you see that this volume can be replaced by in terms of mass. So therefore I can write that the same equation is mass of the solid. So mass of the solid into this volume can be written as mass by volume of the density of the solid. So m by density of the solid I am taking, that has to be rho into what is there, rho liquid is there into G minus mg is there. This is the as a step what we have to be considered. Now you see that mg is nothing but mass of the solid, so common term is there, take it outside. Therefore I can get T is equal to mg is common into rho liquid divided by rho solid minus 1. This is the term. This is nothing but FB. This term is nothing but FB minus W. This is the term what we get here. Now please see that since here the system is a non-inertial frame which is converted into inertial, we have to be write G effective. So therefore G effective, here also G effective, and here has to be G effective. So take care of that. So G effective, yes. Now please see that mass of the substance is given as to be 2 and G effective is 12 divided by density of the liquid. Here water is given, therefore 1000 divided by density of the solid is given as to be 500 minus 1 is there. Therefore T is equal to, this is 1 and this term becomes to 1. and I can write that 24 Newton. So this is the first part answer. Now for the second case, suppose the thread is snaps. So when you cut the thread, since density of the solid is less when compared to the density of the liquid, because this is 500, for water it is 1000, so therefore the sphere, that object will be moving upward direction. So for a second case, the net motion of the sphere is in upward direction. The upward force is F by on C and the downward force is W, because there is no tension since the thread is cut. So therefore you just see that the net acceleration has to be A dash. For example, for this sphere, A dash is acceleration of the sphere with respect to beaker. Okay, now you see that by Newton's second law, F net is equal to M into A. So that is A dash. So that is F net is nothing but FB minus W. So therefore FB minus W, that is equal to M into A dash. The value of FB minus W is there, so I can directly substitute these results from here. So now you see that yes, this result is directly used here. So since FB minus W is already substituted and this value is found to be, yes, now you see that. So therefore I can say that this step, this value is already given there. Therefore mg effective into rho liquid by rho solid minus 1 that is equal to m into A dash. This m gets cancelled out. Therefore I can write that has to be G effective. Therefore A dash, that is equal to G effective is nothing but 12 into this is 1000 divided by 500 minus 1. Therefore 12 meter per second square. This is the A dash value. So this is the acceleration of the sphere when it is when the thread is cut from the system. Please note down the solution, student.